When you think about a modern medical device, you probably picture this huge, sterile, totally automated factory, right? But what if I told you that one of the most well-known devices out there, the silicone breast implant, is actually made with a shocking amount of hands-on artistry? Well, today, we're going to pull back the curtain on that intricate and honestly pretty unexpected process.
So that's the big question, isn't it? Is this thing a product of pure high-tech science, churned out by robots in a lab? Or is it something more like a piece of handcrafted art? You know, as we're about to see, the real answer is this fascinating blend of both. And that's the puzzle we're putting together today.
So, where does a journey like this even start? Well, it's not with the roar of a giant machine. It actually starts with the quiet, focused, and steady hands of a skilled person. That single, manual movement is the very foundation for all the high-tech stuff that comes next. Kinda wild, right?
All right, first things first, we've got to make the implant's outer casing, or its shell. This is the part that holds everything together, so it has to be absolutely perfect. So, how on earth do you make something that important?
It all comes down to this really cool three-step dance between art and science. It starts with a hand dip, then it's cured in a super precise oven, and finally, it's stripped off the mold by hand. Let's dig into that first step, that crucial dip.
This is really where the magic begins. A technician takes this breast-shaped form, it's called a mandrel, and dips it just one time into a vat of liquid silicone. Now think about that for a second. The entire quality, the consistency of the shell, it all hinges on the skill of this one single human-led movement. There are no do-overs.
And boom, just like that, we flip from human craft to hard science. That dip shell goes into a curing oven where the temperature and the time are controlled down to the second. This is what kicks off polymerization, the chemical reaction that solidifies the silicone. And get this, it's so precise that they even capture and treat the solvent vapors. That's a serious commitment to safety.
Okay, so the shell is perfectly cured, but it's still stuck on its mold. The next step, actually getting it off, is where you get a real, tangible feel for just how incredible this material is.
Yeah, you're not going to find a robot doing this job. It takes a person with an unbelievably steady hand, a razor blade, and just pure skill to carefully peel that solid silicon shell off the form. It's a super delicate operation that really requires a feel for the material.
And that moment, right there, just says it all. The very fact that a worker can stretch and peel this thin shell, with a razor blade no less, without it tearing, well, that's a powerful visual testament to its strength and flexibility. It's like a built-in stress test, proving how durable this medical-grade silicone really is.
Okay, so now we have this strong, perfectly formed shell. But at this point, it's totally anonymous. So the next stage is all about giving it a unique identity. This is a hugely critical step for safety and for traceability down the road.
And this is just so important for safety. On the inside of every single shell, they stamp the size, the manufacturer, and a totally unique serial number. And what's really clever is that it's printed backward on the inside so you can read it perfectly from the outside. This means every implant can be tracked for its entire life, which is absolutely vital for patient safety.
During manufacturing, there's a little opening left in the shell. Now, sealing this hole is way more complex than it sounds. A specialized, highly engineered patch is applied in this very intricate process. That seal has to be perfect because it's what prevents leaks and guarantees the implant's integrity for the long haul.
All right, now that we have a sealed, identified shell, it's time for the final transformation. This is where the implant gets filled, finished, and fully prepared to become a sterile medical device ready for the operating room.
So the shell gets filled with silicone gel, but it's probably not the gel you're picturing. At first, the uncured gel is super fluid, almost like water. It's only after that filled shell goes back into an oven for a second curing that the gel solidifies into that familiar, stable, and cohesive form we all recognize.
And here we are at the final, meticulous home stretch. After that last cure locks the gel in place, the whole implant is sterilized in a slow oven process. Then it's placed in sterile packaging, and finally, it's boxed up with all the patient info, the warranties, tracking stickers, the whole shebang. Every single step is one last check for quality and total patient safety.
And there you have it. That's the complete journey. What we end up with isn't just a factory product. It's this incredible fusion of two completely different worlds. The absolute precision of high-tech engineering meeting the irreplaceable, hands-on skill of human craftsmanship. It's the collision of those two things that creates this medical marvel.
And this brings us to a really interesting final thought. You know, we live in a world that tends to put automation and mass production on a pedestal. So, does finding out about the hidden craftsmanship, the actual human touch and skill that goes into a high-tech medical device like this, does that change how you think about it? How you value it? It's definitely something to think about.